Question name is shortest path with alternating colors. The problem is you are given an integer n, the number of nodes in a directed graph where the nodes are labeled from 0 to n minus 1. Each edge is red or blue in this graph, and there could be self edges and parallel edges. Okay. So you are given two arrays, red edges and blue edges, where red edges of I is AI and BI indicates that there is directed red edge from node AI to node BI, and blue edge of I indicates that there is a blue edge from node UI to VI. Return an answer array of length n where each answer of x means each answer of this each index of this answer is the length of the shortest path from node 0 to node x. Shortest length of the shortest path from node 0 to every node. We have to return length of the shortest path from node 0 to every node. 0 to 0, 0 to 1, 0 to 2. If n is 3, 0 to 1, 0 to 0, 0 to 2. Such that the edge colors alternate along the path. Means if we are finding a path from 0 to 2, then there should be alternating edge like 0 to 1, 1 to 2. 0 to 1 is red. If 0 to 1 is red, then 1 to 2, the edge of 1 to 2 should be blue. Or we are finding a path 0 directly 0 to 2, then it can be any color. So in such a way that edge colors alternate along the path, or if there is no path exist in alternating colors edges, so we can return -1 for that. Okay, so the problem is first we will there is red edges and blue edges. We will make a graph with the help of red edges and blue edges. In first problem there is only red edges from in between 0 to 1 and between 1 to 2, and then is 3, n is 3. So we will take one answer array. In this answer array we have to return 0 to 0 path, 0 to 1 path, 0 to 2 path. Okay, so is there exist any path 0 to 0 where edges are alternate? Yeah. Oh, there is always exist a path 0 to 0 where edges are, because there is no edge, so edges are alternate. Okay, and its distance is 0. Is there any path from 0 to 1 when in such a way this edges color of edges is alternate? Okay, yes, always. Why? Because there is only one edge. It can be blue or red. It is alternate. So I'll say its path's length is 1. Is there any path 0 to 2? Yes, there is path 0 to 1, then 1 to 2. And their edges are alternate in color. No, it is red and it is also red. So we can't say there is any path is exist. So we'll say the answer is -1. If here this edge is blue, if in this question this edge is blue, then we will say there is one path exist 0 to 1 and 1 to 2. There is one path exists 0 to 2, which is going from 0 to 1 and 1 to 2, and their edges are alternate in color, so the length of the path is 2. So we'll do this question with VFS. Firstly, what we'll do, we'll make a graph from red edges and blue edges. Okay, take a cube. We'll take a cube, and we'll take a cube of pair. In pair, what I am storing? I am storing 0, because 0 can go from 0 can like 0 can go from blue edge also and red edge also. So I am taking first a queue of pair. In that pair I will say, because we have to go from 0, so I am storing 0. This 0 is representing node n. For color, for like say red color, I am storing 1. I am storing 1. Like for 0, I can say 0 is not coming from anywhere. 0, we have to take care of the edge. The edge from 1 is coming. Like 1 is coming from red edge. So we can only go to blue edges. For this condition, I am taking this color. This color will represent 0 is coming from which color. 0 is not coming from any color. So initially I will say store 0 and 1. 1 for blue or red. Okay, 1 for red. I will say in queue push this. Also will say, I will say push 0 and -1. -1 I am taking for blue. -1 I am taking for blue. So 0 is not coming from anywhere. We have to grow. We have to go. We have to go every node from 0. We have to go every node from 0. So I will say 0 is coming from red also and blue also. Red also and blue also. Then we will take care of is, if one is coming from red, I will update this color. If one is coming from red, then I will search for blue edges from 1. Blue edges from 1. Okay, if here is 3, if 3 is coming from blue, then I will search red edges from 3 to another nodes. So in this way I can solve. The code is very simple. I have taken a graph of red edges and I have taken a graph of blue edges. Okay, I have taken a graph of red edges and of blue edges. Okay, so I am just storing I am making the graph. It is the way of making a graph. I am storing. We can go from AI to BI. It is directed graph. Okay, so I can go from AI to BI from a red edge. And here I can go from UI to VI from a blue edge. So it is the answer. It is the result. It is the vector of pair of result. It is temporary. I will at last I will use this answer, vector of answer, the vector name answer. Temporary, I am using this result to storing the length of every node. So I'm taking a queue which is pair of int comma int. Initially I will say 0 is coming from 1, 1 is representing red, and 0 is coming from -1. -1 is representing blue. Now current distance is a distance from for current the for because we have to find the minimum. We have to find the shortest path. So I am taking this result. In result I will say, now initially I am taking two variable. I am taking vector of pair of int comma int. Pair, why pair? Because for 0th node there can be answer from blue and there can be answer for red from red. So I am storing, initially there is answer from blue edge. It is maximum. The length of the path is maximum, and the answer is coming from blue is length of the path is maximum. So as I will continue, I will find the length if it is, because for any node, like here 0, 1, 2, 3 and this. Okay, let's say this is red, and this is red, this is blue, and this is blue. So what I am saying I can come to 2. There are two paths. I can come from 0 to 1, 1 to 3, and 3 to 2. Length of the path is 3. Okay, I can come from 0 to 2 directly. The length of the path is 1. So that result, why I am taking if the length of the path which is already I have stored, if it is greater than this length of the path, this current distance is less than this path, I will update its length. I will say its length is 1. If it is not greater, I will continue. So initially I have said for 0 the distance is 0, from for the 0 the result is 0 from blue edge and from red edge. In this queue I have pushed the 0 from red edge and from blue edge. Now for every adjacent I am traversing. For every adjacent of 0 I am traversing. Okay, so now the size is 1. I am traversing. I have taken the node in the first in the pair. The first value is representing node and second value is representing its color. Okay, now if the color is 1, color 1 is representing red color. If I have came from one first color, I am came from red color. I have came from red color. So now what I have to search for which colors node, for which color edges I have to search? I have to search for blue color edges, for blue color edges of 1. Am I right? So if I am coming from 1, I am coming from red edges, I will search in blue edge. This B adjacent means blue edge array, blue edge graph. So I will search in blue edge graph and say if the distance, the first value is representing blue edge distance, blue edges distance. The distance, the answer is coming from blue edges. So I will say if the first is greater than current distance plus 1. Current distance means its distance and plus 1, this edge. Its distance, already it is having 0 distance. Its distance and plus 1. Its distance and plus 1. If it is less than its answer, which is initially its answer is maximum. So if 0 plus 1 is maximum, if 0 plus 1 is less than its current distance, I will say update its distance. Update. I will say push it in queue and update its distance. Okay. Now if I am coming from -1, it is not 1, color is not 1, means color is -1. If I am coming from -1, means I am coming from blue edge. If I am coming from blue edge, I will search in red edges. I will search for red edges. Okay, I will search for red edges. So this result dot second, what is representing? It is representing the answer is coming from red edges. The answer is coming from red edges. So if its answer is greater than current distance plus 1, I will say push it in queue and update the answer. Update the answer. And after this loop, after I have gone to every adjacent. I will say current distance plus 1. I will say increase this current distance, because I have gone from every adjacent. Now increase its current distance. Okay. So from this I can find every answer. So I'm taking a vector of int is answer. Now I will check. I will check in both of the I will check this result I have taken now, pair of int comma int. So I will check from both of the edges what the answer is coming. From red edge the answer, what the Okay, first is representing blue edge. From blue edge, what is the what the answer is coming? From red edge, what is the answer? So I have to take the minimum of them. I have to take minimum of them. If minimum of them is int max, okay, it can possible, no? For any edge, answer is not possible. We can't go that edge. We can't go to that node, okay? Because the sorry the this this graph is directed, so I have to take care of it. This graph is directed, so it can possible for any node the path is the path is not possible. So there can be answer is int max. From red edge and from blue edge, the answer is not coming, so it is int max, because initially I have stored int max for every node. So if it is int max, means the path is not exist. If path is not exist, I have to return -1. I have to return -1. If alternate path is not exist, I have to return -1. If it is not int max, then I will say return temp. I will say store temp. At last, I will return the my answer. You can submit the code. So it is running successfully.